Hello and welcome everyone to our webinar today, Software and Blockchain Liability with Howard Elliott. At Experts Direct, we source expert witnesses for litigation. We've worked on many complex matters and matters that involve issues that are often too complex to be resolved by a court alone. Expert evidence is oftentimes necessary to assist both the parties and the court to understand complex issues in a litigated case. And to properly understand complex issues and address them, it's important to have the correct expert on the case. So our presenter today is Howard Elliott, an information technology expert with over 30 years diverse industry experience. And the need for Howard's expertise has come up a lot recently, so it's great to be able to have Howard join us today. Howard is the CEO and principal of Telemetrics Proprietary Limited and has a breadth of experience extending to e-commerce, telecommunications, data networks, communication, and general technology consulting. As an experienced expert witness, Howard has been retained on a number of occasions in matters pertaining to e-commerce, telecommunication software, contract resolutions, and software and system development. In today's session, Howard will discuss liability and other legal issues associated with software litigation and the use of blockchain technology. So just a few housekeeping matters before we kick off. The webinar today is being recorded and a copy of the webinar will be sent to all registrants via email. If you could keep your mics and cameras off for the duration of the session, that would be great. And please feel free to ask any questions via the chat function, ensuring your chat is set to everyone. And we will answer questions at the end of the session. So now I'll pass over to Howard.
Good morning. My name is Howard Elliott. As Erica introduced, I've been in the industry for about 35 years and have worked in most parts of the industry, but mainly in high-speed telecommunications and payment systems. That tends to be where my expertise lies. So, as mentioned before, this will be an overview of software development and the trends affecting the various software development models. In particular, the move from traditional software development to Agile and now on to blockchain. So I believe that questions can be put in the chat and we'll address those at the end. So on we'll go. So traditional software development methodologies generally use a multi-phased approach. These are also known as waterfall or sequential methodologies. And as you can see in the diagram, the phases are quite distinct and they often overlap. However, it is generally a design, build, test model, very standard kind of model. There are usually very clear, enumerable and measurable artifacts produced within each phase. These artifacts are typically seen as outputs from one phase and prerequisites for the next phase. For example, a detailed design would be produced in the design phase and used as a prerequisite for the development phase. Test plans are usually produced in the requirements specification phase, but used as prerequisites for the testing phase. The key mantra is that requirements are developed and agreed with the client before any development work takes place, and acceptance is based on these requirements. There are a number of well-known and well-documented methodologies dating as far back as the 1980s. These include things like Military Standard 498, which was probably the predecessor to most modern day methodologies. Today, we see a lot more methodologies, the most common being Prince2 and PMBOK or PMBOK. Building a contract structure around waterfall methodologies is quite straightforward. Clear, enumerable and measurable artifacts are produced which simplify determination of what was delivered. Requirements traceability matrices, which is a fancy name for a document that just describes what the customer originally wanted and what was actually delivered. And functional test reports greatly simplify the fit for purpose question. There's a large amount of documentation which contains extensive history of the development and the issues encountered within the project. And acceptance can be implemented at each stage. Contracts can be drafted simply and in a similar form to most building and construction contracts. The key advantage of traditional development methodologies is that they are very deterministic. They generally result in fit-for-purpose deliverable, and if properly managed, can tolerate changes and variations in a mature manner. These forms of contract are well understood and well documented. However, software development has moved on from simply writing computer programs. In fact, these days, the amount of code written for a specific project has now fallen to a very, very small percentage of the overall development. This is because most software development these days has generally moved to an orchestration model. This is especially true in web and business developments, most commonly seen. Orchestration means gathering a number of components and players and combining and manipulating them to achieve the desired outcome. So there's some key factors around modern software development. The first one is modularization of software into components and libraries of components. So instead of handcrafting all the features of a computer program, developers can now make use of extensive libraries of already developed components. These components can be very simple components, such as text input boxes, date and number pickers, or more complex components which might display data sourced from a background server. An example of this is often seen on websites which display feeds from social media like Facebook and Twitter. These modules are usually highly configurable. That is, most attributes such as size, shape, color, location on screen, text fonts, borders, and shadowing, they can be easily configured or adjusted without any code development. Some components can be developed by combining other components. And a simple example of this might be a city selection component, typically a drop-down list of cities, which also displays the weather information at that city. This is a component which sources data from the background server. A simplistic analogy to this component model would be the Lego product. As you can see in the pictures, they start with very simple blocks, but quite complex things can be built using those blocks. And Lego produces a number of pre-built components, which allow things like small people to appear and other bits and pieces. With regard to development platforms and tools, these are now also aligned with the modularization and componentry. And there's many, many development tools and platforms available to the software developer. These tools and platforms take advantage of the modular components and can be very advanced. They range from what is generally known as starters or themes and include platforms for developers generally known as integrated development environments or IDEs. As an example, consider the development of a mobile application for a restaurant. Typical functions include things like ordering, locating the restaurant, making a booking. Let me see if I can flip over to this example easily, and I'll show you what this looks like. I should turn my camera off. Can you see what's going on? New share, so stand by sports fans, and I'll go to that one. Okay, so now you should be able to see my screen, which is from the Ionic marketplace. Ionic is probably one of the more popular mobile web development tools. You might also have heard of a product called React, but this starter which I've brought up here is the restaurant starter. And what that starter lets you do out of the box is a whole pile of interesting stuff, from registration to authentication, to placing calls to restaurants, interacting with the phone hardware, building menu pages, pages of the restaurant's menu, I should say, and making bookings. All of that will cost you the princely sum of $20 US. which is not bad. You can see from the description, this is a very, very feature-rich startup. And there are many, many of these. This is just one example, which I thought was quite across everything. So at $20, it's probably not a bad place to start. So let me go back to the PowerPoint now. So back to modern software development. Let's move on to prototyping and design tools. So moving to other recent advances, in particular, most recently, we've seen the rise of prototyping tools. And these are tools which support iterative development through greater involvement with the client. And these tools create working prototypes, which are used to define and in some cases define client requirements, which are used to refine and in some cases define client requirements. And a well-known example of an interactive prototyping tool is a product called Figma. I need to turn my camera back on again. So let me show you Figma for those of you that are not familiar with Figma. So you should be able to see my Figma screen. So this is a prototyping tool called Figma. It's probably one of the more popular prototyping tools for web development. And with this tool, you lay out each screen of the mobile device and add stuff into there and basically build up what your mobile application will look like and how it will perform. Having done that prototype, you can then hit the play button and that will actually make that prototype work. And so you can log in and you can keep going through your application and you can look at various parts of the screen through all the normal application as you would, through the normal navigation as you would expect it to be on a typical mobile device. So this is not a working mobile application. This is just a prototype. Now, having done that, you can make changes on the fly. If I just simply change some text, rerun it. And you'll see that that text has changed and is still in the prototype stage. So that tool is used quite a lot. You'll notice that it's on, by the way, I'm not trying to sell this tool. This tool is on the internet, which means I can have the same session open with the client and I can run through the entire prototyping with them. And with that tool, I can describe the screens, how they're going to look. I can put all the fonts in place, all the colors in place. Go back to PowerPoint. Modern software development now has also embraced iterative recursive development. The modularity of components, the development platforms, and the interactive prototyping tools lead to greater involvement with the client and what is generally known as iterative development. The development paradigm typically starts with a prototype, and over a series of iterations involving significant client interaction and feedback, the functionality of the system is increased and refined. Well-managed iterative development generally leads to more reliable outcomes. That is, the client's involved throughout the process as the system functionality and features are refined. However, in the iterative development models, the client takes on a greater responsibility for the outcome, and hence the liability shift. What is not apparent in the iterative development models is the presence of detailed requirements and detailed design documentation developed prior to the software being built. Like the system itself, these documents are also developed in an iterative fashion. This presents difficulties for contract formation as there are no clear deliverables until the project is actually completed. So the risks in this type of project are typically quite high. The most common failing is the project becomes effectively a time and materials or a do and charge project. In a similar way that project management methodologies were built around the sequential or waterfall models, so too are methodologies being built for iterative development. Enter Agile. Agile methodologies are generally more iterative or evolutionary in both the development of the software and the development of the requirements. Agile methodologies are characterized by a large number of versions of the software, each more evolved than the previous version. Agile's heuristic approach takes the most recent output in a trial and error style model to develop the next iteration or version. There are a number of well-known Agile methodologies. Scrum and its derivatives are probably the most well-known. Kanban, which is Japanese for signboard, is rising in popularity and also quite well-known. Surprisingly, Scrum was created in the 1990s, and today it's probably the most widely used and well-known. And the figure on the screen is from the Scrum Guide, and it shows the key components of Scrum. The Agile project starts with a very high-level requirement, often called user stories, which are evolved progressively through close interaction with the customer. User stories start out in a very high-level fashion and are typically of the form, as a user type, I want to be able to perform some function. For example, a user story might be, as a logged-on user, I want to be able to see the menu for the restaurant. As a logged-on user, I want to be able to make a booking at the restaurant. They're typical user stories. High-level user stories are often called epics, and over time developed to include a number of subsidiary user stories. These subsidiary user stories provide the fine detail of the overall function. So core to Scrum is a sprint. And a sprint can be thought of as a mini project. It might be a few days to a few months long, typically a few weeks. And the output of a sprint is an increment or iteration of the software being developed. In general terms, the increment should be sufficiently distinct from the previous increment to allow an informed decision to be made about the next increment. The start of a sprint usually involves a sprint planning meeting at which the deliverables for that sprint are agreed. Generally, these deliverables are known as the backlog. Backlog items are those which can be delivered in that sprint. They might be partially working components of the system, they might be documents, they might be interfaces to data sources, but they're always mapped back to the requirements or the user stories. So let's move on to the contract construction and the issues associated with that. The most common failing which I see is that lawyers attempt to build a contract using precedents designed for sequential and waterfall methodologies. And key to this is determining acceptance and fit for purpose, both of which in the sequential model depend on requirements. Most importantly, in constructing a contract around an agile development, it's important to understand the liability shift previously discussed. In an agile model, responsibility for fit for purpose is shared between the development team and the customer. Not surprisingly, I find the greatest challenge is in having the customer accept this. This shared responsibility, when managed well, includes not just the fit for purpose issue, but also the time and cost elements. So how to form a contract? I'll use the Scrum methodology as the basis for this next discussion. These on the slide, you can see the key items to include in a contract where agile development is being used. Let's go through some of these key things because they're quite important. The product vision is the original high-level statement by the customer on what they're trying to achieve. It's important to capture this as it provides the bounds for the project and can be used to identify major variations. The detail in the product vision reflects the detail understood by the customer. It may be a brief description or it may be very detailed. The product owner is the key representative of the customer. He or she is responsible for communicating the customer's vision of and requirements for the project to the development team. Scrum Master ensures that the development team and the product owner are working cooperatively and following the Scrum processes. The Scrum Master may be from the developer or the customer. But most importantly, the Scrum Master should be experienced in Scrum and be able to keep the development team and the customer within the bounds of the methodology. The Scrum Master is the person who has immediate knowledge of things in the project which are not going well. This is such a critical role that I often recommend that the customer engages the Scrum Master. The development team will be responsible for the actual development activities within each sprint. The product backlog, or the backlog, is a prioritized list of all the items that are to be developed during the course of the project as described. It is agreed during each sprint planning meeting and reviewed for completeness at each sprint review meeting. User stories, as previously discussed, are a natural language description of features of the product being developed. And the formal definition of sprint is it's a short time-boxed period during which the development works complete a set amount of items in the product backlog. Moving on to some of the contract components themselves. First, in the contract, we usually put in the performance objectives. And we use this section to outline things such as the product vision, high-level technical functions, high-level business functions, who the primary end users are and their high-level needs, what development approach is being used and what description of systems to be used, that is the infrastructure if applicable, and any ongoing processes for evaluating and determining any change in scope. Bunch of responsibilities of the individuals, the key individuals in the contract. The product owner, for example, is nominated and appointed by the customer. The product owner must be suitably experienced in Scrum development projects. And their responsibilities include the initial development and prioritization of the product backlog, the ongoing revision and reprioritization of the backlog as the project develops, and participation on behalf of the customer in Scrum planning and review meetings. It's very important that the customer makes the product owner available and dedicates a reasonable amount of their time and efforts to the above activities. Their involvement in the project is absolutely critical. They need to respond to questions from the development team as soon as possible. The development team typically identifies who is carrying out the development and any internal processes which need to be observed. Often this section will identify key individuals and require that they remain part of the team throughout the project. The Scrum Master, here the contract will determine who will provide the Scrum Master. Whoever provides the Scrum Master must ensure the Scrum Master has an appropriate level of skill, experience, and qualifications to carry out the duties and responsibility of a Scrum Master for the project. The contract will typically reference in the standard duties and responsibilities of the Scrum Master from the official methodology documentation, which as of this webinar is the 2020 Scrum Guide, which can be found at scrumguides.org for those of you that are interested. And I think Eric is going to put that in the chat so everybody can see it, no doubt. And the provider, whoever provides a Scrum Master, must ensure that the Scrum Master is dedicated to the project during the development period. They're a very critical player. The product backlog section contains key details on how the backlog will be managed. This includes sprint planning and review meetings. So for example, the product owner and the development team will meet within 10 days of the date of this agreement to discuss the development of the initial product backlog, for example. The product backlog might be released within 30 days of the date of the agreement. These kind of clauses are quite common. The parties will hold workshops during each sprint or sprint meetings in order to refine or amend the backlog. and determine which items in the product backlog will be developed in each sprint. Within a certain period of development of the backlog, or the development team will typically provide the product owner with an estimate of the effort required to develop each item in the product backlog. Then the supplier must ensure that its estimates are prepared with appropriate care and skill, of course. And once those estimates of effort have been finalised, the product owner will assign priorities to them. That all happens in the sprint meetings. This section will also identify how and when the product owner can amend the product backlog and any restrictions on that, such as the product owner can't unilaterally change any estimates of effort, and it cannot unilaterally change the scope or priority of any of the items. So they're typically restrictions that you put in the contract at this point. Section on sprints typically includes the duration of each sprint. For example, you might say that each sprint will be no more than 4 weeks. It might say that the duration of an individual sprint cannot be extended. Sometimes they can. It should also identify what to do with items that are unfinished after a sprint. Should unfinished items after a sprint be reinserted into the backlog, or should they be moved forward to the next sprint? These are decisions often taken by the team as a whole, but signed off by the product owner. Also in here is the schedule for sprint planning meetings. And they're typically held prior to the start of a sprint, well prior, which allows the development team to resource up if required. Key things to happen at each sprint meeting include stuff like the development team identify how many of the high priority items can be developed during the sprint and what the done criteria is for these items. And I'll speak about done in a moment. So other things for consideration is that all the sprint items are typically fixed for that sprint, and any improvements agreed at the sprint review meeting are implemented by the development team in the next sprint. There's usually clauses in here about what completes a sprint, and typically a sprint is completed when the items in each sprint have been accepted, done, or rescheduled to the next sprint. Let's talk a bit about done, because this is a term that is used a lot in Scrum methodology. So items developed in the sprint are deemed to be done, completed, when, for example, agreed tests have been conducted and passed, such as user acceptance tests and non-functional tests. They might be done when all the code has been reviewed or peer reviewed, but all coding standards have been met, code has been refactored where necessary, and all necessary documentation has been completed. So it's not a detailed set of acceptance criteria, but it's usually a brief set of acceptance criteria on a per backlog item. And during each sprint planning meeting, the product owner and the development team may agree on additional criteria for done for specific sprints and for specific items. Also in this section is who actually will manage the sprint meetings. Typically it's the Scrum Master, and they're the ones that will run the meetings and make sure all the documentation is maintained. So one thing which is often overlooked in many Agile development projects that I've come across is the need to keep the project documented. And to do that, there's a number of tools available, typically from companies like Atlassian, which produce quite good tools to help you manage these kind of projects. But from a legal perspective, they provide a trail, an evidence trail of what's actually occurred in the project. And it's critical that those tools are used in well-managed projects, I should say. Project completion includes definition of how the project will be defined as completed. And that could be something simple as all the product backlog has been done. Usually in completion, the supplier will prepare things like documentation, product descriptions, which were part of the original deliverable set, and which have been developed during the project. May include how the software is to be handed over to the customer, what deployment models are in play. Typically, it will include the infrastructure and who owns the infrastructure and how the project is ultimately deployed onto that infrastructure. So that sort of briefly runs through the key requirements of an Agile contract. It's a topic which I can spend a lot of time on. We have a lot of precedents now for Agile contracts. They are quite different to a sequential contract. And most recently, we've been building statements of work to fit into a typical master services agreement framework. So let's move on now to the final topic, which is blockchain. So I'm not going to talk too much about the underlying technology for blockchain, because that will take a whole webinar in itself. But I will talk briefly about the development of applications using blockchain. Because if you're involved in development of applications on blockchain, there's some key things to be aware of. And this actually includes the development of the blockchain itself. Firstly, it's important to understand that blockchain encompasses much more than just cryptocurrencies. There are many, many applications being developed on blockchains that do not involve cryptocurrencies. And some of these applications include distribution and procurement management applications. In fact, one of the more famous ones is being done by West Australian Government and the Australian Wheat Board, and it involves grain distribution from the farm to the loaf of bread on the table. Quite a complex one, but very early adopters. Other ones include government licensing applications. So there's a number of applications around at the moment. As you know, sorry, if you're from New South Wales, you'll know about our Service New South Wales application and the government licensing applications, and how long it's taken the government to be able to consolidate all those into one location. They're still not complete. But the modern technology now for licensing uses blockchain and uses tokens that are underlying there to keep that, to keep the transparency and the security of those applications going. And the other area which we see a lot of is digital rights management, typically involving tokens such as NFTs or non-fungible tokens. So digital rights management, you'll see a lot of that come up in the near future. There are many music, movie, media applications which are coming online now. Probably one of the more common ones is a thing called OpenSea. OpenSea is a marketplace for digital media, and it's probably the best known place for artists to create digital media works, be it music or video or art, attach an NFT to it, and then put it on a global marketplace for sale. So blockchain is a distributed environment of peer nodes. That is, rather than a central server, there are multiple servers distributed over a wide area. Often that distribution is across jurisdictional and sovereign boundaries. Blockchains can be public, like Ethereum or Bitcoin, or private, or you can build your own. The choice depends on the applications to be developed. Blockchain is kind of a derivative of cryptography and based on very advanced cryptographic algorithms and mathematics. In fact, the algorithms on which it's based also form the basis of most of our payment system security, and they're known as PKI, public key infrastructure algorithms. And despite much fear, uncertainty, and doubts to the contrary, it is highly secure and much more resilient to cyber attack than most other systems because of this cryptographic underpinning. In blockchain, you'll hear terms such as smart contracts and tokens. Most blockchains these days include what is known as the native token for that particular blockchain. For the Ethereum blockchain, the token is ETH or ETH. Another term you'll hear used a lot is dApps or dApps. And dApps are the applications which sit on the blockchain. dApp is short for distributed application. Applications being developed on blockchain typically use an agile model. So much of the previous slides are relevant for forming a development contract. The key feature of public blockchains like Bitcoin or Ethereum or Sol is that they are a public record of transactions. That is, anyone can look into the blockchain and see the transactions which have taken place. In fact, there are many tools available to search blockchains and produce reports of transactions. And we use these tools to trace the flow of tokens across the blockchain. That said, some blockchains, such as Bitcoin, have limited or no identification information. And while we can trace a transaction, we don't necessarily know the personal details of the individuals involved. In today's world, most central banks are researching cryptocurrencies and most regulatory agencies are doing the same. And this is now seeing regulatory frameworks being rolled out in most jurisdictions, which address fraud, AML, and KYC. AML is short for anti-money laundering and often includes counter-terrorism financing in its title. KYC is know your customer. And this is a set of requirements for banks and other designated service providers to keep very detailed records of who their customers are. These are very rigid regulations here in Australia and mandated under the AML-CTF Act. And many jurisdictions now across the world are requiring crypto exchanges to comply with KYC requirements. And those jurisdictions include Australia at the moment. So if you sign up to BTC Markets or FTX Australia or Binance Australia, you have to go through detailed KYC in order for them to identify who you are. So that's the end of blockchain. Sorry it has been so brief. If you have any questions, I think I should hand back to Erica at this point and just do that.
Excellent. Thank you, Howard. That was a very informative session. I think the evolution of software development, even in just the last 20 years, the pace of the development has been phenomenal, and understanding technical elements of software development is critical for lawyers to understand, as it permeates so many different areas of legal practice. So you mentioned that with Agile, there's a liability shift so that the obligations and responsibilities for fit for purpose and time and cost, it's a shared model within Agile. So in your experience, what kind of pushback do you see being experienced because this is a shared model of liability between, so it's not just, the onus isn't just on the designer, but it's shared with the customer as well. What kind of customer pushback is usually experienced in that regard?
So I'm going to move my lips around because it says I can't unmute myself again.
Oh, okay. Well, let's just fix that.
We probably have the right amount of words coming out.
Yes.
Apologies.
Howard, we can hear you. It's fine. Yeah, Howard, we can hear you.
Or I could talk loudly and be heard through your...
Oh, yes. Well,
we can hear you, Howard.
To do that. Let's see.
Loudly, and I'll try and address that question. It's not a simple black and white answer. As most of you know, software development contracts can be quite small. They can be sub $50,000, can be sub $20,000. They can also be very large, hundreds of millions of dollars. Most of the large banks, when they're replacing their core banking systems like Westpac and CBA and NAB in the last 20 years, have spent in excess of $1.4, $1.5 billion each doing their software development for that.
So it can be very big, can be very small. In traditional software development and software acquisition, the form of contract has been driven by the lawyers, and no offence intended, of course, but it's been driven by the lawyers because the nature of the formation of the contract is very straightforward when it's a construction contract, and that model is taken forward as well. The liability for fit for purpose, on time, on budget, rests with the vendor, the supplier. The customer can sit back and generally deal with contract variations, but usually the liability or the responsibility exists solely with the vendor. With the more modern application development contracts, there's much more involvement with the client. And so that liability has to shift. It's required to shift in order to make those development projects work properly. It doesn't matter whether the project is quite small, sub $100,000, for example, or sub $50,000, or whether it's quite large. The amount of customer involvement is still relatively quite high. What we generally find is as project gets much larger, there is typically an overarching contract such as a master services agreement. And then within that master services agreement, there'll be a number of statements of work which cover individual projects within the larger construct. That's no different to older systems or older approaches, but it is important that that's done for agile contracts at a large scale. I guess the key requirement I keep coming back to is the involvement of the customer. It is the most difficult thing to get across to the customer because they're not used to doing it. If you pick up any of the analogies that are used for agile, the most common one is either building a house or building a wardrobe of clothing. When you build a house using agile, you start with a box. And then you walk in the box and say, oh, I'll have a door over there. Oh, no, I won't. I'll just move it a little bit over to that side. Oh, no, it won't there. I'll put it somewhere else completely. You can do that quite comfortably, but you need to appreciate that there are bounds. As a customer, you need to appreciate there are bounds in which you can do that. Likewise, the vendor, if well educated and following the method, can assist with where those bounds are. Did that answer the question?
It did, thank you. And that customer buy-in is obviously critical in the parties coming to agreement on what done looks like at the end of the day. So yes, that's great. And we've also had another question. Thank you very much, Howard. How are disputes resolved in Web3? And what are your views on Aragon/Claro and the likes of those? Oh, and there's a third element. And do you think there's a need for something else? I have to say, that's all double Dutch to me, so I'll hand over to you.
There's about 27 questions tied up in there. So let's go with the easy one first, and that's with dispute resolution. The form of dispute resolution that you put in agile contracts is no different to the form you put in a normal contract. I would recommend that ADR kicks in quite quickly, and in a normal construction project, there is typically meetings between executives before you get to an external party, such as a mediator or adjudicator or an arbitrator gets involved. We would recommend the same thing. Would not recommend going to court because, actually, no, I would recommend that because I get hired to explain how this stuff works. It's very complex. Most agile projects tend not to do, most well-managed agile projects tend not to get to that level. They will get to the mediator level, and they'll typically use an expert determiner more so than any other kind of ADR to get along to that. That's dispute resolution. Web3. Really? Okay. So for those on the call that don't understand what that means, basically, probably the simplistic way of describing Web3 is that once upon a time, we used to have simple computers running out of data centers, and we had PCs and stuff connected to those, and arguably they were Web 1 and Web 2. The difference between Web 1 and Web 2 is fundamentally that the power of the computer shifted down to things like laptops. So a lot more processing was done on the client device. The Web3 is a bit of a quantum leap, nothing to do with quantum computing. That's my next seminar. Bit of a quantum leap. So Web3 now is looking at the distribution of server resources across a wide area on the fly. This is very difficult to grasp unless you're kind of deeply into the tech. But it basically means you'll be able to develop applications and run them in the cloud, but the infrastructure that runs them is fully distributed. And one day it might be running in China, the next day it might be running in Nicaragua, the next day it might be running in New York, who knows? At the same time, it's running, parts of it might be running in different locations. So those underlying infrastructure components get delivered on an on-demand basis. And I apologize to the people on the call who actually do know what this is, and I'm really trying to simplify it. But it's suffice to say that it is a very, very distributed model. It's also very new. We're currently going through trying now to work out the best way of delivering Web 3.0. And one of the more common applications that you see on things like Web 3.0 is gaming. There are a number of sites in the US, like Wings, for example, who run very, very sophisticated gaming networks. And they use these Web 3.0 models to provide their underlying compute power. And part of the reason for that is that their gaming systems, sorry, what Wings does, by the way, if you've got a lot of money that you don't need anymore, you can go on Wings and you can buy an American football team, a virtual one. And these virtual American football teams, which play American football on the screen, using some very clever graphics, you can buy and sell players. And these players are named and they have histories and they train and they get injuries and all sorts of stuff. And guess what? There's gambling on there as well. So gambling and advertising. And this is one of the very early forerunners into things like metaverse. But the way the gaming systems work is because there are so many things happening on their systems which are not interconnected. So there might be a game happening over in that part, and there'll be another game in a different part. And so that distribution of power is required for those kinds of things. So you see a lot in those kind of applications. I think there's a long way to go in Web 3.0 before we kind of have to worry about it in mainstream. Generally, what we tend to worry about here in mainstream is more standard blockchain applications. Which one did I forget? You want to know which tokens to invest in? Sorry, this is not financial advice. I can't tell you.
Is that Aragon and Claro?
Yeah, so they're all examples of different blockchains.
Right.
And each of those will have their own token on top of that. There are more blockchains around than you can poke a stick at. I didn't even go into the ICOs, but if you're interested in the blockchain version, I guess, or the crypto version of IPOs, there's a whole pile of ICO sites, which stands for initial coin offering. And if you just go glance at those, you'll see how many of these things there are. There are a number of sites around which keep track of where blockchains are up to, all the different blockchains. And you'll see there are hundreds and hundreds of these things around. Some of them are very dedicated, some of them are layered. So sitting, probably the most well-known blockchain is Ethereum, and that tends to drive, or has in the past driven, a lot of the technology, such as smart contracts. And sitting on top of Ethereum are a number of other networks which have their own token based on top of that as well. So it can become quite complex. And
yes.
As I said, you want to talk about blockchain, it's going to take you another webinar.
I can imagine. I can imagine. I mean,
too much.
Yes, and it just gives rise to a myriad of very complex legal issues. So you know, it's evident that having expertise in the nature of yours it does provide that assistance to the courts and the parties in understanding those complexities, and then being able to take that practical knowledge and translate it into the legal terms in a contract.
So today, the most common question that we have to deal with, or that I get to deal with, is typically one of what the jurisdictional boundaries are and how they affect transactions. My technical background, as I mentioned, is payments. I spent a long time with MasterCard and Visa. So cross-jurisdictional payments are a nightmare. They're just a nightmare. Blockchain complicates that by having the actual coins which are being used, or the currency which is being used, also distributed. And that makes cross-jurisdictional issues quite difficult. Makes the ownership quite difficult, the provenance quite difficult. Most recently, we've seen theft of tokens, typically Bitcoin. Don't know why that would be the case. They're only $50,000 each. But typically we see theft of Bitcoin, and that usually arises because of a breach of keys, a breach of the credentials. So somebody's stolen the keys and been able to get into the blockchain. And as I mentioned before, Bitcoin and other blockchains are quite open. You see all these transactions floating around the place. Can't necessarily see who they are, but you can see where they've all gone. There's a bunch of companies formed out of the US, most recently with assistance from the FBI, to now trace these things and put heuristics in place which match individuals' behaviour on certain systems, from Facebook to Twitter to Bitcoin exchanges, and then to be able to identify who's actually got these Bitcoins. So that we're getting there gradually. And over a period of time, the KYC will kick in place. So here in Australia, it's key. In the United States, it's key, where you have to go through KYC in order to open up an account on an exchange, on a crypto exchange.
No, it's fascinating. And you can see the challenges for regulators, governments, lawyers, you know, alike in keeping up with the very fast moving landscape in this area. So I don't think we have any other questions. Thank you again, Howard, for joining us today. It's been a very informative webinar. And as I mentioned at the beginning of the session, you will receive, all registrants will receive a recording of the webinar today. So thank you, Howard. Thank you, everyone, for attending, and enjoy the rest of your day.